Hi, I'm Steven. You're watching Steven Loves Science. Now, in the last video, we discussed the standard Pivnert equation, which works great for problems where there is no change going on. But sometimes chemists need to account for problems where there is going to be a change in volume and a change in pressure and a change in temperature. So for that, we use this modified Pivnert equation, which is initial pressure times initial volume over initial temperature equals final pressure times final volume over final temperature. So now let's go to work with the problem. Once again, I'm going to try to get the problem to come up in the text, so it should be coming up there right now. A small bubble rises from the bottom of a lake where the temperature and pressure are 8 degrees and 6.4 atmospheres to the water surface, where the temperature is 25 degrees Celsius and the pressure is 1 atm. Calculate the final volume in milliliters of the bubble if its initial volume was 2.1 milliliters. So, we have this bubble that is under a lot of pressure at the bottom of the lake and is going to rise up to the top of the lake, and its volume, we should see its volume increasing. But to solve these types of problems, some people find it useful to draw a picture of your two bubbles. So, we have our initial bubble, where the pressure is 6.4 atmospheres, the volume is 2.1 milliliters, and the temperature is 8 degrees Celsius, which is equal to 281 Kelvin. And then we have our final bubble, which is going to have a pressure of 1 atm, an unknown volume, and a temperature of 25 degrees Celsius, which is 298 Kelvin. Move that back over there. So, once again, let's rearrange this equation so that we end up with final volume, which is what we want. So, rearranging the equation, we can get final volume is equal to initial volume times initial pressure over final pressure times final temperature over initial temperature. So now let's go ahead and plug in the values for the problem that we're working with. So using the same equation, the initial volume for our problem was 2.1 milliliters. Once again, I'm going to omit the units just because it takes up too much space on the board. Times our initial pressure, which is 6.4 atm, over our final pressure, which is going to be 1 atm. I guess I'll put in the units. Times our final temperature, which is going to be 298 Kelvin, over our initial temperature, which was 281 Kelvin. And carrying out this problem, we should get that final volume is equal to 14 milliliters. And if you're wondering what I'm looking at, I wrote it in front of me on another board, so I would not have to go ahead and do the calculation as we did this problem. So that's about as simple as it gets for these problems. I hope to get into harder problems as we continue on.